Let's now consider review problem 1.3. Find the mean, standard deviation, and 12.5% trimmed mean and 20% trimmed mean of this data set. First off, the mean is easy. Simply do 5 plus 8 plus 12 plus 13 plus 15 plus the two 16s plus 27 and divide by the total number of entries, which is 8, and that will be the mean, x bar. And so doing the arithmetic, we get a mean of 14. To get the sample standard deviation, we subtract 14 from all of these. So negative 9, 8 minus 14 is negative 6, 12 minus 14 is negative 2, 13 minus 14 is negative 1, 15 minus 14 is 1, 16 minus 14 is 2, I get that twice, and finally 27 minus 14 is 13. Okay, then I square all of these. Add them up. Divide by 7, and then take the square root of the quotient. So that will be the sample standard deviation. So doing the arithmetic, I get the square root of 300 over 7, which is approximately 6.547 to 3 decimal places. As we'll discuss in a later review problem, the standard deviation gives a measure of how spread out the numbers are. The next thing we need is the 12.5% trimmed mean. To get the 12.5% trim mean, that means we remove the lowest 12% and the highest 12.5% of the numbers. So we omit the lowest 12.5% and the highest 12.5%. In our case, 12.5%, we have 8 entries, and so the 12.5% trim mean is obtained by simply omitting the lowest entry and the highest entry. Remove the lowest eighth and the highest eighth, and then taking the average of what's left. And so we have 8.8 plus 12 plus 13 plus 15 plus 16 plus 16, all divided by 6. And this works out to be 40/3. Lastly, we need the 20% trim mean. We can't omit the lowest 20% and the highest 20%, so what we need to do is interpolate. So the 25% trim mean we can figure out. We can't figure out the 20% directly by just simply omitting the lowest 20% and the highest 20%, because 20% of 8 does not work out to be an integer. However, we can find the 25% trim mean by omitting the lowest 25%, the lowest quarter, and the highest quarter. So the 25% trim mean will be 12 plus 13 plus 15 plus 16, all divided by 4. And that works out to be 14. Okay, so to get the 20% trim mean, we need to interpolate. So let me clear off the top of the screen here. So to get the 20% trim mean, essentially what I need to do is find the line that connects these points and then find the coordinate that matches. So let me demonstrate this. So here's 12.5% trim mean is here, and the 12.5% trim mean occurs at 40 thirds. Whereas the 25% trim mean occurs at a slightly different y-coordinate of 14. So the idea of finding the 20% trim mean is that I'll draw a line between these 2 points, and whatever the y-coordinate is that corresponds to 20, I'll figure out the y-coordinate that corresponds to 20, and then whatever that number is over here that matches, that will be the 20% trim mean. To do this, we'll basically find the equation of this line. So the slope of this line is 14 minus 40 thirds divided by 25 minus 12.5. And doing the arithmetic, we get this. The slope works out to be 4/75. And so using the point slope form of a line, we get that y minus y1, and let me use the 14 number here. Just for simplicity's sake, it doesn't really matter which one I use. Y minus 14 is equal to 4/75 times x minus x1, and I'll use the 25 number. And so to get the 20% trim mean, we replace x by 20 and solve for y. So 14 plus 4/75 times 20 minus 25. Okay, so now that we have all this, let me clear out the bottom down here. And so doing the arithmetic, we get that the 40%, or say the 20% trim mean is 13.73 bar, or written as a fraction, 13 and 11/15. So that is the technique to use interpolation to figure out a trim mean where the trimming does not correspond to an integer number of entries.